Are having our next speaker, and he will be addressing on mastering essential strategies for optimal cloud infrastructure. And please, ladies and gentlemen, welcome Mr. Akhthar Parvez, CEO of TechBrein. He is the founder and CEO of TechBrein, and he possesses over 20 years of experience in infrastructure management domain. And prior to establishing his TechBrein, he is also an alumnus of Model Polytech College, Kalyasheri, a co-committee member of CAFIT, and also he has served as a senior system engineer at IBM. A man with a lot of expertise in hand, and he's here with us. The stage is all yours, sir. Welcome to KTX.
Good morning, distinguished ladies and gentlemen. I'm Akhthar Parvez, a CEO at TechBrein, and I'm very happy to present my session, Mastering Essential Strategies for Optimal Cloud Infrastructure. Before I start my session, may I know how many SaaS product owners are here? That's good. So how many of you are from infrastructure management or cloud infrastructure management side? I mean, CTOs, system administrators, DevOps engineers. Can you please raise your hand? Great. Okay. So I believe the rest of them are tech enthusiasts, and I'm glad to see this diverse audience. Okay. So basically, I asked this question because I wanted to understand my audience so that I can actually optimize my speech accordingly. The slide was already there, but I could optimize how I am explaining these things by understanding the audience. Okay. So actually, I have done two things here. First, I initiated the process of setting a strategy. Okay. So strategy is all about asking questions, understanding the objectives, and learning about the target audience. These things, and the second thing why I have asked these questions are I can optimize what I'm going to talk, as I've told. Okay, so what is optimization? Optimization is a process of doing certain things which can improve which can make whatever you're doing as efficient as possible. So these are the two things which I'm going to cover today as well. Okay. So let's start with the introduction. I hope all of you are aware about, are familiar with the cloud computing. So what is cloud computing? Cloud computing is a technology that's used to build the infrastructure to run your applications, and a flexible and scalable infrastructure to run your applications. Okay. There are, as you know, there are 4 different types of cloud. One is public cloud, which most of you are using. Major IaaS vendors, other like AWS, Azure, Google Cloud. These are actually available on the public. Okay. Then there is private cloud, which you can actually create in your on-premises infrastructure, and which will be only available to you. Okay. Third, there is hybrid, where you can actually utilize both the public and private part of cloud. And then there is multi-cloud, where you can actually combine different cloud vendors. So how did cloud get its name? Cloud actually, you know, as you actually, most of you might have known this already, and for the rest of you, it's actually taken from the cloud on the sky. So how are these clouds on the sky formed? As you may know, it's formed by a group of droplets are being formed to create a shape which is flexible, and more droplets can actually combine. That makes it scalable as well, okay? And that also makes it limitless, and that's somewhere on residing somewhere, right? So the cloud computing or cloud infrastructure has all these characteristics, and it was also pretty easy to use this symbol of cloud. When you have to draw diagrams, it's very easy to draw that. So actually I just introduced about the server infrastructure, the history of server infrastructure in my earlier part before we start the session. So server infrastructure previously were actually formed by dedicated servers, which physical servers, which were actually running the applications. Okay, and you could actually create the you could create scalable architecture with physical servers by scaling it horizontally or even vertically. Okay. So what is horizontal scaling? Horizontal scaling is scale out. Like you can actually, for example, there is a physical server or a cloud instance. Then you can add more instances as your demand goes up. Okay, that's what horizontal scaling is called. Vertical scaling, that is actually pretty useful, and because it doesn't have any downtime, your application won't have any downtime, because you can actually add more instances or computing power when you have more demand, and then if you have less demand, you can actually scale it down. Vertical scaling is upgrading your currently running infrastructure so that or the computing, using more computing power, which means there would be a slight downtime as you have to shut down the existing instance and start a upgrade instance, right? So initially server infrastructure, since they were physical servers, it was a bit difficult to scale up or scale to scale horizontally or vertically. Okay, so that's why the cloud computing was formed. Actually, it was formed by this one single physical server could have actually made into various different sizes of virtual environments, and these virtual environments can actually then again be combined from different physical servers to form a single infrastructure. That's how the cloud infrastructure is formed. And finally, what is cloud optimization? And in my previous slide, I have discussed about what optimization is. Optimization is actually improving your existing cloud infrastructure by performing various tasks to increase the performance or to meet your business objectives. Okay, and to increase the ROI. So as you can see here, this is the cloud infra triangle theory. So a cloud infrastructure triangle is, there are three sides of triangle. One is security, the other side is performance, and the third side is cost. So by default, when you increase one of these sides, like security or performance, as you can see, that's the baseline. Security is on the left, so and cost is on the right. So when you try to increase either side of things, security or performance, cost actually increase. That's how it works, right? From one end, actually, if you try to increase the line of security or increase the line of performance, the cost side also gets increased, right? So here actually I have shown two triangles. The first one is the blue triangle is actually that actually utilizes a limited level of security and performance. Thus, the cost is also less. Okay, as you can see from that blue triangle. And there are different colors of triangles. I'll explain why there are different colors of triangles. And then you can also see the green triangle. That's actually a bigger triangle, because here I have to increase the security, and I also have to increase the performance due to the demand or my business objective, thus the cost have also got increased, right? So by default, cost increases proportionally to either performance or security. And now you can see three sets of, each set having three triangles, right? So again, as I've told you, by default, cost increases when you increase security or performance. But then you can actually, this is actually by default, I'm expecting it to be unoptimized. So when you try to optimize it, so the SOC that you have seen is, as you can see there, here performance and security, that side is actually the size of that side, the length of that side is exactly same as before, but the cost side has come down. That's because we have actually optimized to improve the performance. So we have actually run various tasks to better utilize the resources that we have. That's how it works. Then finally we have the balancely optimized cloud, where we actually reduce the security and performance side according to the business objectives. Because in some cases we may not be needing all of the security options available we have, or even we don't have to use all performance opportunities available, because our business objectives have certain limits. Like we have budget, and we have a very clear idea how much users are going to use this application, or where these users are going to come from. Okay, so depending on these, we can actually build our strategy. Okay, so this is actually the cloud infrastructure triangle theory. And in the green triangle also you can see these three triangles. The lighter one is actually default cloud infrastructure, which definitely has more cost. Second one is the standard optimized, where you have this same performance and security, but the cost side is less. And on the third triangle, you have less security and performance. You have slightly reduced the security and performance to meet the business objectives. Thus, the cost have come drastically. Okay. So this is the cloud infrastructure triangle theory, and this is very important to understand this, so that you can actually build your infrastructure to run your SaaS application, or any application that you are running on your infrastructure. So let me talk about optimal strategy for cloud infrastructure deployment. So as you have seen in the beginning, I have asked certain questions to understand the objectives of my session. Okay, to understand about the target audience, to understand what the audience need. Based on these, actually I can, and based on this I can optimize session. Okay, so similarly here we have to understand business objectives. Like, for example, if you have if you are building an cloud infrastructure for your ERP application, you need to know how many users are going to use this. Okay, or if you are running any e-commerce application, you need to know how many end users are going to use this initially. So you have to prepare according to this, and you also have to take a budget into the consideration, because as I said, we are not going to build we shouldn't be actually building the maximum performance or security infrastructure. We have to build a balancedly optimized infrastructure to meet with your business objectives. Then according to this, we need to evaluate the workload requirements. Now we have a very clear idea what we need to build, what are the kind of applications that we are running on the cloud. So based on this, we need to make sure we use the specific, we understand we also have to take into consideration of which all technologies are being used, and depending on this, we understand the workload requirements. Then once we have these information, we can actually choose the right cloud model. Okay, because I have in my earlier I talked about 4 different types of cloud, right? Private, public, hybrid, all these different types of cloud. And based on this, we need to select the right cloud model. And as I said, if you're using public platforms, there are many public platforms available like AWS, Azure, or Google Cloud. So we need to choose which one. We need to understand which one is more suitable for us, right? So once this is done, we have to define an architectural design. And this architectural design actually involves about creating an optimized, a unique infrastructure for to run your applications. Okay, be it for your SaaS application or e-commerce application or an ERP application that your enterprise is using, which is running on the cloud. Then finally, see, once we have the architectural design is ready, we need to use the optimum resources. See, because it's very important to have the adequate resources so that your application doesn't cause any, the infrastructure doesn't cause any problems for your application. And it's also very important to make sure the infrastructure is being utilized properly. Okay, if you have a large infrastructure and your application is actually using a very small part of it, you are actually bleeding a lot of money, right? And then you also have to implement various security and compliance. And then once all these are done, we are ready to deploy. And as soon as this is deployed, you also have to continuously iterate and improve the performance, security, and cost, and optimize to improve the performance, security, and cost. So, as I said, the three different triangles of cloud is performance, security, and cost. So we have to optimize the cloud infrastructure for all these sites, right? So firstly, we have to build the infrastructure for an optimum performance. So how do we build this? Okay, so we have to select the adequate virtual machines and other resources to get the applications running seamlessly. Then we also have to use auto scaling where it's required, because auto scaling actually has, if your e-commerce application is, if the demand is going to be pretty high at different times, you can actually leverage this auto scaling technology. Then you also have to implement load balancing wherever it's required, so that you can actually distribute your the demand for the request among different instances, right? Then you can actually use optimized storage, because the cloud infrastructure has different kinds of storage blocks to meet with various objectives. For example, some of them might not be needing a lot of I/O transactions. Then others, while on the other side, some application or process might be needing a lot of I/O resources. So based on all these things, you have different types of storages. So we need to use the adequate storage so that we get the maximum storage performance. Then see, for example, see, if your application is having performance issues, it's not the most people actually just upgrade the cloud infrastructure, thus bleeding a lot of money. Unfortunately, infrastructure is not the stumbling block or the root cause of these performance issues, at least most of the time. Okay, so there, if you straight away go to upgrade your cloud infrastructure, you are going to bleed a lot of money. And if you are having a SaaS product, it's going to be very difficult for you to manage your SaaS business, right? So what you have got to do is you have to make sure the server which is running on top of this cloud infrastructure is actually optimized to run your application, because each application has different architecture. So based on this, you have got to optimize your servers. Then there is also a database optimization, where you have to optimize your database tables, indexes, queries. So in some cases, optimizing tables or adding indexes or modifying the queries slightly can actually improve the performance, maybe up to 20 to 50%. You can see there could also be scope to improve your application code, because that might be causing performance issues. In those cases, you also have to look whether you can actually optimize your application so that it will use less resources. Okay. And you could also make use of serverless computing, so you don't have to run the entire part of your application from the computing instances. So you can use the serverless architecture, which can actually be leveraged to run some part of the application which uses large infrastructure. And finally, we also have to perform. You also have to perform performance monitoring and tuning to make sure your application or whatever things you are running on your cloud infrastructure are running very smoothly. And on the security strategy, we have to follow with identity and access management with role-based access control, because we have to follow the zero trust security policy, where you shouldn't be trusting any of the people who are using the cloud infrastructure. You shouldn't be providing them with permissions or access control which they should be requiring. Okay. Then you also have to make use of two-factor authentication to prevent any kind of hacking of your individual email account, which can actually cause a lot of problem for the security. Then there are a lot of network security options available, like you can actually set up DDoS protection. You can actually make use of virtual private cloud if some part of your cloud infrastructure are not don't have to be accessible from the outside. For example, databases or other microservices which don't have to be accessed from the outside. You can actually put those things into a private cloud, a virtual private cloud. Then you should also make use of data encryption both on the transit and while on rest. So while on rest, when they are stored on in databases or storage, you have to make sure the data is encrypted so that your customer data is not affected. Then there are a lot of threat detection options available, where you have to ensure whatever threats for your applications are actually being monitored and detected as soon as possible, and then any post-incident jobs are being performed. Then on the security side, on cloud security side, you also have to take care of data governance and compliance, because when you depends on where you are actually serving your application, because you have to, and the industry you are working with, like if you are actually collecting payment from your customers, you have to follow PCI DSS, Payment Card Interface Data Security Standard. Then if you are actually storing the healthcare information of your customers, you have to adhere to the HIPAA certification. So there are different kind of compliance that you have to follow. Then finally, as I said, you have to have incident response and recovery, so that whenever something happens, you need to have a team who can actually pick up these issues and take necessary actions. Then finally, this is the most important part, because most of the people are actually facing issues with the cost side of cloud infrastructure, because as I said, performance side, you can always actually get rid of this by having a bigger infrastructure. Okay. Security side also, mostly all of us are very lucky, because see, we might be passing the road carelessly, and we don't, only very few get hit, right? Similarly, that's what happens with the security as well, because even if you don't have a very secure infrastructure, you may not be hacked. Okay, because especially if you don't have a successful product, because those who are actually trying to hack your infrastructure do want to get something in return, and if you cannot afford what they are trying to demand, they won't be trying to hack your infrastructure. So, uh, and then, but on the cost side, here we actually have a lot of problems, because if you have a less optimized environment, we could actually use, I mean, our cost of running the cloud infrastructure could go very high, which could even impact your SaaS business, because you won't be able to meet your expense, because your revenue would be much, very much less than what your expense is. And once you migrate your infrastructure from on-prem, or if you're migrating your infrastructure from on-premises to the cloud, you may be facing issues with, see, cloud is actually, you get the bill according to the usage, or if you weren't fully prepared, or if the infrastructure is not completely optimized, you are going to get much bigger bill than you are actually hoping to get, or you are actually expecting. So it's very important to optimize the cloud for cost, to reduce the cost, to keep the cost as less as possible. So this is actually done firstly by using the optimum virtual machine resources and other resources that you are using on the cloud. And you also have to make use of auto scaling, because for example, if your application has a lot of application might be having different types of processes that are being run, and mostly on maybe 95% of time it might be using an average level of computing. Okay, so, and at times the application might be requiring bigger computing power based on the usage. For example, if you are creating large reports that might need to, at that point of time, you may need to increase your infrastructure. Okay, but most people actually make a mistake of, they actually build the infrastructure to take care of, or to cater all kinds of processes that are being run as part of your application. Okay, but this is a wrong way of doing things. So you should set up your infrastructure to take care of the 95% of processes that being run. And so for the rest 5%, what you have got to do is you have to auto scale your application. I have explained about horizontal scaling. So when you need more demand, you have to create more instances which can actually provide the additional, which can actually cater the additional demand. Then there is also serverless computing, where you can actually use the additional computing power for a very few point of, for a brief point of time, so that you don't have to have a dedicated resource for this, but you can actually use this serverless computing for from a few minutes to a few hours. Okay, then you could actually use a reserved instance by reducing to reduce your cost by up to 70%, because cloud by default is having pay-as-you-go model, so the price is very high, and most people make a mistake of running their cloud instances with a pay-as-you-go model. But you could actually save your, if your application is running all the time, you could actually convert your instances to reserved instance, so that you can actually reduce the cost. Okay, and then there are spot instances. These are actually unused instances on the cloud infrastructure, which your public cloud infrastructure vendor are allowing you to use it. But the catch is, these spot instances can only be used for a very short time. But see, if you're using a web app, if you're having an e-commerce website or e-commerce application, we know these applications, these requests can be served within a very short point of time, because as you know, the maximum time your system could take to process the request is less than 2 minutes. Okay, so and most of these headless architecture, most of the application with headless architecture can actually process the request within less than a minute. Okay, within less than a second, within a second. Okay, so in these cases, if you use spot instances instead of regular instances, the cost can again be saved by up to 80%. Then we could actually use pay-as-you-go model VM instances where you are actually running applications like ERP application for your business, which is actually used only for limited hours of time. For example, if your application, if your SaaS application is actually being used from morning 9 to 5, you could actually use these you could run these instances just for that period of time from morning 9 to evening 5, and you can actually automate this start and shutdown so that your instances on the cloud infrastructure would only be used when you are actually using the application. Then we also have to do regular cloud cost assessment so that to understand if there are any bleeding points, if there are any underutilized instances, and make necessary optimization. And then there are further options to reduce the cost that are by availing credits and POCs, because almost all cloud vendors are providing with various credit programs. So if you are starting your cloud application, you could actually avail those credits and POCs. Then you could also set up cost alarms to alert you when you are actually utilizing a certain, for example, 90% of your cloud bill. So that's it. Thank you from my side. Thank you for staying very patiently.